Hello and welcome to the Open Systems Media webcast dealing with legacy in industrial IoT. I'm Kurt Schwader, your moderator, with today's speakers Ving Pudicek from DFI America, Veronica Ma from InnoDisk, and Dave Nielsen from Supermicro. Ving is a product manager at DFI America with over 15 years of experience in the embedded and IPC market. Ving specializes in embedded computing and industrial technologies with an emphasis on key segments such as digital signage, IIoT, factory automation, and medical computing. At DFI, Ving analyzes industry product trends to assist in identifying future product requirements, application usage, and specifications for DFI in North America. Veronica Ma is business development at InnoDisk. Veronica is an expert in IoT automation and industrial across multiple market segments. She received her bachelor's degree from Illinois Institute of Technology and master's degree in marketing communication. David Nielsen is senior IoT embedded system product manager with Supermicro. David has been involved in electronics manufacturing for more than 25 years. The majority of his time has been spent focused on embedded applications across a broad spectrum of markets. Today's session will consist of about 50 minutes of presentation, leaving 10 minutes at the end of the hour for audience Q&A. Before we begin, let's run down some important features of your viewing console. It consists of a set of windows you can open, close, resize to your preference. On entry, you'll see the presenter, speaker bio, sponsor, slides where the presentation will be displayed, and a Q&A window that will enable you to ask questions during the event. There are 7 icons across the bottom of your screen. Clicking the icon on the far left will reset your viewing area to a default configuration. The rest of the icons open and close their corresponding windows. You can hover your mouse over them to find out what controls which. Now, clicking the handout icon second from the right opens a handout window which has presenter slides in PDF format so you can use those to follow along with. The Q&A window enables you to participate today. You can simply type your question into the Ask a Question text box, then hit Submit. We encourage you to ask questions throughout the event while the question is fresh in your mind. We'll address as many of these as we can during the closing Q&A. And if you have a question pertaining to the webcast operation itself, you can submit those too, and one of our technicians will be happy to help you. This and all Open Systems Media webcasts are copyrighted and may not be recorded or used in any way without the express written consent of Open Systems Media. On with the show. Ving, the floor is yours.
Great. Thanks, Kurt. The results of arising problems in conventional factories, such as poor work environment, outdated equipment, and bad production efficiency, many existing factories are transforming to smart factories. These smart factories adopt the idea of Industrial 4.0 to enhance productivity, improve product quality, ensure safety, and lower production costs. I'll be going over dealing with legacy in industrial IoT and providing some case scenarios based on our experience. The Industry 4.0 is changing traditional manufacturing into a fully automated, integrated, and optimized production flow. The embedded computing system plays an important role as a centralized controller communicating and interacting with sensors and devices to enable a smart factory. To fulfill the emerging trend, embedded computing manufacturers such as DFI is focusing on revolutionizing AIoT factory solutions, integration with AI, IoT, and 5G to activate existing industrial automation towards the future of smart manufacturing. To realize the full potential of a smart factory, plants should install the latest IoT devices. For new plants, there are essentially no barrier to deploying the latest equipment and IoT devices in order to connect machines together, since they're all installed with the latest OS and I/O that are compatible with one another. However, in old plants, most of the equipment are often 20 years old, 10 or 20 years old, and embedded with legacy I/O such as ISA and PCI slots, or operating systems such as Windows NT or XP that are no longer supported. So confronted with the latest IoT devices paired with the latest I/O and OS, compatibility becomes a problem for an older factory struggling to connect to legacy equipment to new devices. Older factories generally face difficulty in legacy maintenance. As an old hardware reaches end of life, equipment with ISA or PCI slots malfunction, and substitution for non-supported hardware is difficult to locate since product and materials are all designed with the latest PCIe or M.2 I/O card firmware and driver, and installed with the latest operating system. That is to replace malfunctioning hardware with newer products. How to associate the new device with the rest of the legacy equipment and aspects of both hardware and software becomes an issue. In view of these challenges, where legacy industrial equipment presents an obstacle for old plants in either upgrading or maintenance, embedded computing manufacturer like DFI launches IPC refresh program with Intel for legacy IPC upgrading. In the following case, DFI has worked with AUO Optronics to overcome these hardware upgrade problems through IPC refresh. Over 20 years as the machine aged and unexpected failures impacted production, most of the materials like I/O slots, including ISA, PCI, AGP, and so on, faced end of life, and related services were suspended by the suppliers. With over half of the equipment operating in legacy hardware and systems, equipment upgrade took a long time and a lead to huge delays in production. Implementing IoT devices in the factory seems like an ideal but essentially impossible approach. Therefore, DFI proposed a hardware and software compatible controller platform solution architecture to support both AUO's legacy and future processing technologies. The goal of this short-term countermeasure are to reduce manufacturing line shutdown, save equipment renewal costs, minimize development costs, extended life cycle support, enhance performance reliability and efficiency, and add better scalability and flexibility. In the AUO IPC refresh program, DFI utilizes customized embedded motherboards outfitted with ISA I/O and running a virtual machine monitor hypervisor, KVM, and VirtualBox. This enables a series of PCI expansion cards to compatibly execute the logistic storage system and glass cutting machine functionality under Windows XP, and no driver was required to be installed. The IPC provided by DFI achieves application form, fit, and function I/O compatibility, extending the longevity and reliability of the original manufacturing equipment. Slot compatibility with driver cards can be understood easily through outlet of embedded motherboards, but how about the data transmission in between? Simply put, it's similar for making a transition from a Samsung device or an iPhone. Due to a different operating system in the two phones, Android on Samsung, iOS on iPhone, as we want to transfer old data from Samsung to the new iPhone, an app or API is required to smoothly and easily transfer the data from device to device across two different operating systems. Similar to transfer data from legacy hardware to new products, Intel's hypervisor functions as the app and API in order to communicate between these two devices. Next, let's look at Intel's IPC refresh technology. Old IPCs can no longer support heavy, high-performance workloads, so there are several IPCs that should be upgraded for high-performance requirements. However, as the new IPCs cannot support old operating systems such as Windows XP, a middleware or a virtual machine hypervisor is required for the new IPC to operate in the old operating system. Through Intel technology, the virtual machine hypervisor allows operating systems to be adopted into the new IPC. In the IPC refresh program with AUO, the embedded system was a DFI RM641SC. It's a 6th generation Intel Core rack mount PC with a running hypervisor, virtual machine monitor, KVM, and VirtualBox, enabling a series of PCI expansion cards to compatibly execute a machine functioning under Windows XP. The ability of the RM641 SD to successfully support the I/O both legacy and cutting-edge industrial computers is based upon Intel's virtualization technology for directed I/O, or VTD. Intel VTD is a proven technology that provides CPU support for I/O virtualization and also helps applications improve IPC security, reliability, and performance of I/O devices in a virtualized environment. DFI works closely with Intel to adapt VTD on long life cycle industrial applications. In this process, it's necessary to generalize PC via the Windows Test Prep tool and use a CloneZilla tool to extract the legacy images of legacy IPCs. And the last step, they successfully can run on Windows XP. Through AEO's case for outdated interfaces such as ISA slots, to solve this situation, DFI developed an array of industrial motherboards and IPC installing a virtual machine, which was then configured to run Windows XP and application binaries in order to support legacy interfaces that can be compatible with old equipment. Besides ISA slots, several new motherboards with Intel 6, 7, 8, and 9th generation processors that support legacy PCI interfaces to compatibly purpose while upgrading server computing capability. Several embedded systems with Intel 6th generation processors support PCI interfaces to be compatible with old equipment which applied in old factories. As a leading provider of embedded solutions, DFI delivers total solutions for the ever-growing demands of smart manufacturing factories. This total solution covers a wide range of industrial-grade and ruggedized products, including powerful embedded systems, touch panel PCs, low-power embedded boards, and industrial Ethernet switches to fulfill a large variety of tasks during the production. Smart Manufacturing Total Solution offers flexibility, reliability, and cost efficiency for today's factory automation machines. Solution providers look for efficient, optimized IoT device development platforms that accelerate time to market, but more importantly, help satisfy environmental constraints. Extreme environments such as wide temperature range, power fluctuations, severe shock and vibration challenges the consistently reliable performance on a industrial computing platform. These products have the ability to support an astounding minus 40 to 85 Celsius operating temperature with wide voltage DC power input and economically low power consumption without removing real-time computing capability. Expandability modules play a key role in upgrading outdated devices and working IoT solutions on the factory floor. I'll just go over a couple that DFI has used. Energy efficiency is one of the criteria for developing new technologies for applications in small factories that needs not only energy efficiency but also long-distance stability and safe wireless communication. Wi-Sun sensors has been a feasible solution. Wi-Sun modules can act as a group of IOs for your sensors to supply data such as temperature, ultrasonic, light, humidity, etc. It has all the advantages of both Wi-Fi and Bluetooth, but with lower power consumption. Wi-Sun stands for Smart Ubiquitous Network. It's compliant to IEEE 802.15.4G PHY. It provides secure mesh network solutions to smart networks. For each module, it communicates to I/O devices through the UART or I2C. In mesh networks, it composes of individual modules. Each of the modules has a communication range of 1 kilometer and up to 300 nodes in the mesh network. First area in the shop, AIoT factory products are used to achieve the future of factory automation, which is divided into two main areas. The first area is the shop floor in the factory. Since site that gathers and sends equipment data for factory environment monitoring to the edge computing system for preliminary analysis. The second is the control room, where data is received via transmission, such as LTE communication for remote monitoring. DFIU is working with InnoDis to supply InnoAge, which is InnoAge is with Microsoft Azure Sphere inside, plus integration with customized InnoDis firmware, software, and hardware technology. This new solution enables multifunctional management, smart data analysis, and updates, the data security and remote control through the cloud, while benefiting from the power of Azure Sphere to help ensure secure communication between the SSD and cloud. Expandability modules such as this comprehensively help our clients simplify the development of IoT connected devices and generate a complete IoT solution. Oops. So in conclusion, to realize the full potential of a smart factory, plants should install the latest IoT devices. For new plants, there are essentially no barrier to deploying the latest IoT devices. Older plants require IPC refresh paired with the latest IoT device and equipment. The IPCs achieve application form, fit, and function I/O compatibility, extending the longevity and reliability of original manufacturing equipment. Thank you. Back to you, Kurt.
Great, thanks, Ving. I think a lot of good information. That PCI refresh program and the IoT devices for these industrial IoT applications are really interesting. I want to remind the audience, if you have any questions, submit them using your Ask a Question box now and throughout the material. Veronica, you're up next.
Okay, thank you. In next section, we will introduce how AIoT will be implemented into smart factory. Nowadays, smart factoring is no longer the stuff of dreams or science fiction. It's real, and it's taking place at factories around the world. These factories are more efficient and productive as a result. And next page, please. Here we identified 3 scenarios that will drive your business forward. Let's start with the first scenario, the automatic assembly. In the past, you could only imagine a factory run entirely by robots. However, it's no longer the stuff of dreams. Such factories do indeed exist today. Some smart factories are completely automatic. There are almost no need for human intervention. Because there are few human employees, factories can run around the clock. Robots don't need to take breaks or vacations. A factory could consistently operate 24 hours a day, 7 days a week. And here are some limitations. For example, it's difficult in integration with different machines. And 7 hours a day, 7 days a week operation with limit downtime request. Also, it lacks real-time system healthy status monitoring tool. In order to solve those problems, we need a highly integration AIoT-ready solution and 100% industrial grade with solid quality, along with purpose-built iCAP, provides real-time and remote monitoring. Next, second scenario is quality control. Smart factoring equipment has built-in sensors. Those sensors collect a great deal of data about raw materials. Sensors are being trained to identify minute flaws in raw materials or parts needed to complete a product. They can alert human staff that there is a quality control issue before the product even leaves the factory floor. This development could mark the end of expensive, time-consuming recourse as we know. The limitations are difficult in integration with robot arms, industrial communication protocol, and lacking self-learning to improve accuracy. In order to solve those issues, We also need highly integration AIoT ready solution and industrial communication module, and using AI server to improve the engine more accurate. Next, last but not least, the third scenario is the smart warehouse AVG. What does AVG mean? It's an automatic guided vehicle. This is a portable robot that allows along marked long lines or wires on the floor. All users radio waves, vision cameras, magnets, or lasers for navigation. They are most often used in industrial applications to transport very heavy materials around a large industrial building, such as a factory or warehouse. The limitations are in-house positioning and tracking algorithm, battery runtime prediction, and maintenance, also the real-time inventory data report. So we need a complete indoor navigation system, remote access with real-time monitoring, and reduce labor cost and human mistakes. And in next section, we will introduce more detailed system solutions. Next, please. Here we will introduce some AIoT-ready solutions in details. In terms of edge systems, our partner DFI offers HMI in-vehicle touch panel PC and digital signage solution. With the OS support, it could perfectly provide no matter if it is vertical or horizontal installation. It offers great flexibility in smart factory and other applications as well. Also, Box PC, a fanless vehicle system, which is capable of handling more tasks with its rich I/O and provides more opportunities for future expansion. It delivers the capability to improve in-vehicle experience with better reliability in extreme environments. And when we talk about cloud systems, there comes Supermicro AI server, network video recorder server, and storage area network server. The Supermicro Super Server supports the Intel Scalable processors, second generation family, in a high-density 1U form factor. These super servers are very ideal for network, infrastructure, front-end enterprise, and minimum downtime server systems. Next, please. And besides above edge and cloud system, we also need smart components to support. The InnoDisk embedded and server memory series is DRAM made for some environments with extreme temperatures or rapid thermal cycling. These hardy modules are perfect for smart factory applications. All modules surpass the JEDEC standard and are certified for operation in temperatures ranging from minus 40 degrees to 85 degrees. Next, please. iCAP is a browser access management platform that allows you to monitor the status of solid-state drives, memory, and the other components in edge device. It does this by gathering data from all connected devices and storing it on a central server, either on the cloud or on a company internet. From here, the data is easily accessible from your cell phone, pad, or laptop with online access. Next, please. Dynamic user interface improves management experience and make your management simpler and even more efficient. Next, here we listed some graphic images of all the AIoT-ready solutions we just mentioned earlier. And next page, we also talk about more detailed technical specs of cloud systems, so we will not spend time to and go through each details. Next, in conclusion, what we need to do today is to provide software and hardware, even application, and improve product quality, reliability to make the products more competitive. Based on customer demands to make application fulfill industrial application, and always keep in mind to develop and maintain service oriented for customer to achieve a better user experience. That's it. Thank you.
Great. Thanks, Veronica. I think there's a lot of great information there in terms of automated IoT for industrial and factory automation. You mentioned a lot about the sensors and automation there, as well as GUIs and management software and user interfaces, which is also can be important to factory automation as well. Our next speaker is Dave Nielsen. Dave, the floor is yours.
Thank you, Kurt. Good morning, everyone. So just to get started here. Okay, so industrial IoT represents a broad range of markets, from oil and gas, building automation, manufacturing, as well as many others that I haven't listed here. So much of the related infrastructure is in place, and we're seeing a significant amount of opportunity to enhance the functionality of these systems, bringing new performance levels and technologies into legacy environments. So because of the benefits to be gained, operators of industrial equipment are looking to improve operations by adding IoT elements to their existing equipment. There are many design considerations when implementing IoT in a legacy environment. Topics such as product longevity are critical to the planning and implementation of IoT. Not just how long it will be available, but also how long it's already been on the market, indicating a proven track record. Another important topic is, does the new system have the ability to interface with the equipment that is already in place? Here we're talking about legacy ports like the RS-232, 422, and 485, which are very common in legacy environments. Another element to consider is whether the existing software applications will still work on the device. Writing new drivers for an older device in a new system is not always an easy task, even if the original source code is available. So another aspect of the design to consider is whether the new system is sufficiently rugged for the application. Can it withstand the vibration of the machinery? And does it handle the temperature of the environment? Also, does it have the necessary mechanical requirements to mount in the desired location? So designed specifically to address these questions is Supermicro's E100 9AP IA. The IA model offers a wide voltage input of 9 to 36 volts, so no matter what's available within the legacy system, simply connect the 2-wire Phoenix connector to your source supply and power it on. Storage requirements are satisfied with a variety of interface standards, all of which are available from our technology partner InnoDisk. There's room for a 2.5-inch SATA device, as well as M.2 and Mini PCIe, which all can be used concurrently. Mounting methods will vary by application, and with this model we offer wall mount as well as DIN rail, or it could be used in a desktop scenario as well. So if expansion beyond 4 USB, 4 RS-232, 2 gigabit LAN, and 8-bit digital I/O is required, we have the ability to install additional expansion modules. The system's also designed to operate in temperatures ranging from -20 up to 60 degrees Celsius. So as mentioned in the previous slide, this system provides for additional functionality using InnoDisk's adapter modules. We've validated isolated port modules specifically to address legacy environments. By isolating the grounding between the systems, we can protect devices regardless of the ground return path used by other components in the legacy systems. Here's an example of a simple application where legacy equipment may interface with a gateway that collects information from various sources, such as sensors inside the machine or in its raw material delivery, as well as factory environmental conditions. Additionally, you may have vision systems and monitoring the output of the equipment for quality control. Data is aggregated and moved on for further processing or action by facility management. So in addition to our industrial automation specific model, Supermicro offers a full line of fanless systems to be used as gateways or standalone systems in a variety of markets. From our very compact and low-power Intel Atom-based solutions to our latest Core Series product supporting Celeron to i7, we offer a range of performance and features to choose from. I'd like to highlight a couple of these new systems in this product family. The first up is our E109W series based on the latest Intel mobile processors. These are available in performance levels from Celeron to i7 with features such as USB 3.1 Gen 2 for 10 gigabit speeds, multiple LAN, and a variety of M.2 form factors to support storage as well as I.O. cards such as cellular and Wi-Fi. These systems also feature multiple display outputs such as HDMI and DisplayPort for driving today's common displays. Another new product I would like to highlight is our E3029D based on Intel's second generation Xeon D processor. This is a unique product in the market offering 8 LANs, 4 of which are 10 gigabit. As a fanless system, it not only offers the ruggedness for manufacturing environments, it offers the performance of Xeon processors outside the data center. With the additional expandability from the M.2 and PCI Express, this system brings performance and flexibility to the edge. So all this talk of gateways and data collection leads us to the inevitable topic of what to do with all the data that's being collected. For years, all the talk was of sending all this data to the cloud to be analyzed and applied to machine learning and artificial intelligence. Today, we're seeing tremendous growth in the application of artificial intelligence at the edge. Bringing AI closer to the data reduces the latency and increases the benefit of collecting the information. In my earlier example of the gateway in a factory, we can now see how this information can be processed and acted upon in real time when and where it's collected. Operators can have faster response time, offering cost savings from reduced downtime and predictive maintenance, instead of relying on routine schedules that may not consider the conditions that the machine is experiencing. To address this, Supermicro has launched new powerful edge devices that work across many markets. Our NVIDIA NGC-ready systems provide support for multiple GPUs in sizes that fit most applications. Since the expansion is based on the PCI Express bus, these systems are perfect for any variety of applications that require expansion capability, not just specifically GPUs, but could be other custom cards, FPGAs, and likewise. So I'd like to just quickly highlight a couple of these new systems. First, our E40390 is based on the Intel Xeon D platform and is available in a number of core counts and frequencies. As you can see, this system offers a tremendous amount of network connectivity with 13 LAN ports, 4 of which are capable of 10 gigabit speeds. Adding to the three PCI Express cards makes this system a powerful tool for industrial automation. For applications requiring more performance, we can take advantage of the E4039P, which offers the same amount of PCI Express expansion, but is based on the latest Intel Xeon Scalable processors. This system will support CPUs up to 28 cores, 205 watts. Thank you, and back to Kurt for Q&A.
Great, thanks, Dave. We are now to the Q&A. Again, I want to remind the audience to continue to ask questions. We've got some in the queue, but we've got plenty of time for Q&A, so take advantage of the expertise we have here. Let's start with a question for Ving here. How significant is having a long life product availability in smart factories?
Thanks, Kurt. It's a big deal. When a product goes EOL, you're out scrambling to find replacement that has similar specifications to the old hardware, and in addition, must work with the existing software. So qualifying a new product takes up a lot of the organization time and resource, and not to mention about recertifying the new equipment as well. So integrators want to look for at companies that offer embedded solutions. Usually there will be IoT product roadmaps, which offers a 15-year or even a little bit longer life cycles, utilizing the latest Intel embedded roadmap. So it is a big deal, especially in smart factories, just to reduce the cost and the resources to source another product.
Okay, great, thanks. Let's see, Veronica, in what situations would conventional temperature memory or extended wide temperature memory be necessary for day-to-day operations within systems throughout the factory?
Great question. So essentially there are two different types of systems that are deployed directly within a factory environment. You have ones that are of the high-performance service system nature that are normally deployed and stored within an isolated, air-conditioned environment. These normally can utilize the conventional temperature grade from 0 to 85 degrees, whereas you have the other box type IPC systems that are normally deployed directly at the floor or on the factory floor, working alongside other automated tools and so forth. And so with these, they're exposed to other external environmental factors such as surrounding heat, thermal buildup, and such. And so the other variety of memory temperatures that are offered is your wide temperature that is extended from -40 to 85 degrees. And so you have these two temperature modules that complement the two different sets of classifications of server systems that are out there that are deployed directly throughout the factory.
Okay. So I guess you've got to just kind of do an environmental analysis and determine what the threshold temperature ranges are for the application and make sure you're using the memory that fits that application.
That's correct.
Great. So let's see here. Dave, I think there was a question about you had a lot of systems that you mentioned there. Do you have any sort of customization for fanless operation?
Yeah, thanks, Kurt. So all these systems, all Supermicro systems, are available fully configured. So there's the full range of variability that you can have with whether it's the different processor or the different memory and storage. We do entertain certainly custom opportunities, and we're always happy to discuss customer-specific needs. So if anybody was interested in something that is, let's say, like these products, but we're missing on a certain item that they require, and also if the one example I gave of a system where we utilize the InnoDisk expansion modules, there's a lot more flexibility there. If you're just looking to add a couple of ports, a couple more LAN ports, or maybe you need more RS-232, so there's always that opportunity as well.
Okay, I see. There's a question that I think we can kind of go around the horn, and maybe we can start with Dave and the others can comment. There's just kind of a general question. You've got a lot of good information about systems and dealing with the legacy equipment. If I'm someone out there with an application and I have my SMART goal for my SMART system, and I have a starting point, which is what my system looks like now, which has legacy systems in it, is there any guidance or recipe out there where they can kind of go step by step to achieve incremental successes before they get to the ultimate goal? Do you recommend prototyping? Can you just give us a little bit of a lay of the land, Dave, and then we'll go to the other two?
Yeah, certainly. It is a big challenge to adapt or adopt IoT into some of these legacy environments. When you imagine a factory floor that is with aging equipment, you're bringing in newer interfaces, faster speed buses. It's not always easy to integrate that. So you do want to work with a company to talk about what's available, what benefits can be achieved, and usually that's based on the sensors that you're looking to install. So what kind of information are you trying to gather, and what are you going to do with it? And then that takes you to the farther back end. Are you trying to implement artificial intelligence? A lot of companies and the metrics today are saying that most companies are looking to use that type of analytics and machine learning, but there is still a high wall or barrier to get there when we're dealing with some of these much older factory environments. So I would recommend speaking directly to a company like Supermicro to talk about how you want to interface with your equipment, what types of sensors you're bringing in, and then go from there.
Right. So I guess you're saying kind of take stock in what you have now and the kind of data capabilities, and then incrementally add sensors to get wins, and try to leverage a smart smart partner.
Well, to know. Yeah, and to know your goals, right? What are your goals, and then go from there, because sometimes there's the request we need to add IoT because that's what everybody's doing, but that's not always the smartest approach, right? You need to know what the benefits are to you and your business, and then bring it in intelligently.
All right, great. And Veronica, and I apologize, we also have a special industry expert for InnoDesk, so maybe you can introduce yourself as well. What are your thoughts on, taking stock of a smart factory goal, like many of the advanced features that Veronica talked about, and I have my factory now, what's the recipe to get from here to there?
Oh, hi, hello. Here we also have our product manager, John Wu, here, so he will help share with some information about the smart factory.
Great, thanks.
Hi, good morning, everyone. So in regards to our insight from an Innovid standpoint, in where we provide solutions of the flash storage and DRAM memory nature to our customers for optimizing their respective applications. And so going on forward to your question on how the smart factory environment can best be optimized for the long term, being challenged with how systems are currently being outdated right now, how certain items and resources are heading towards a more of a legacy standpoint. For our standpoint, I would say that we have certain memories as part of our portfolio, such as server-registered RDIMMs that can provide higher scale capacities, and furthermore are built using 3DS or TSV technologies to help transcend the performance barriers of these respective systems so that they can work alongside whatever type of data that they're trying to crunch out to help everything process data rapidly within that nature. On the other side, there's also system classifications that was mentioned by both our colleagues from DFI and Supermicro. These are of the box type industrial IPCs that are more commonly deployed directly on a factory floor. And so these use more of a legacy type of storage and DRAM components, and so we have products that are geared directly for automatic assembling, one for quality control and such, modules that date back to SDRAM, DDR1, DDR2, and PCIe and so forth that can help deploy and function alongside these respective systems.
Yes. And also these IPC systems are dedicated to single specific tasks that delivers the factory assembly line. And so some people don't really require the high performance types of memories that required for server systems. So using the unbuffered memory, which is also one of our solutions, can have a different grade of components and software technology is more ideal. Yes. So this is our comment. Yeah.
Okay, great. And Ving, I mean, you talked a lot about this IPC refresh program. That seems to be specifically targeted toward, environments where people are trying to get from a current system with perhaps aging machines and kind of do an incremental update. Do you have any kind of recipe or experience with how these kind of companies have kind of upgraded their system successfully into the new IoT world?
Yeah, so companies in factory automation and other vertical markets are seeking to maximize the benefits of IoT, and we're seeing a lot of requests for products that are scalable and upgradable, flexible and expandable, robustness, reliable, available, and serviceability. And trying to do that on a legacy platform, it can be a challenge. I think, as Dave mentioned previously on one of his slides. So what DFI has offered is allowing products that have programs set up in our space to allow customers to upgrade their specific PC, as I mentioned, with hypervisor and some of the virtualizations that are available. So one of the things that DFI does have also is IoT solutions off the shelf as well, which provides some ready-made products that are certified and for the factory floor. They are industrial-grade components and industrial-grade systems. So we have a wide variety of solutions that are targeted for this particular space, especially for manufacturers that are looking to upgrade the machines.
All right, great. Another good question for probably each of you from your different perspectives. We'll start with Dave. How should system designers plan for an internet cloud outage? This is kind of an interesting thing because, is there a role where edge systems can play a part, or should people kind of restrict their cloud systems to more, non-real-time data analysis and analytics and make sure the edge is capable of taking over if you do end up with some intermittent outages?
Yeah, I think that's exactly what we're seeing today. Is a lot of our customers are looking to do that. It's a redundancy. They enjoy the benefits of the cloud, but they recognize that the cloud is can feel like a distant place, right, where all your data is stored, and if there is an outage, as you say, there can be issues. I'll give you an example. For retail, where you have a connected store and all of the transactional data is being managed in the cloud. Well, what happens when they lose their connectivity, even briefly, right, for a short period of time? If transactions are happening, you don't want to tell the people in line that you can no longer take their credit cards or process the payment because you've lost that functionality. So there's a lot of redundancy being built in with edge systems.
Okay, yeah, that makes a lot of sense. InnoDisk, the folks at InnoDisk, in terms of smart factories, this is especially important. I guess it has memory implications on the edge to make sure you can do any kind of buffering and storage and intelligent operations at the edge. Are you seeing any sort of designs or anything to be able to accommodate those things if you do have some kind of cloud outage?
Working alongside of some of our customers, being customers from the data center side, even to the edge computing side that you have mentioned, we have seen, as requested and discussed among our customers, that these are issues that they have faced in the past. And so working alongside them, we have produced solutions to these ongoing challenges that you have referenced and mentioned. Some of our products, especially being noted on the flash storage side, we built titanium capacitors to hold storage charges so that if there was on the off chance an abrupt power outage or these applications were to suddenly crash or drop, there would be a last-minute flash of the data that was ongoing, that was to be processing throughout whatever transactions were ongoing, to be immediately stored within the flash storage chips of our product, so that our customers are not faced with any kind of abrupt conditions if they were to resume their back to their normal day-to-day operations after some spontaneous or random power outage or crash.
And also
Yeah, and
our our iCAP platform can allow the customers to remote monitoring all the solid-state drive memory and other components in edge device.
Yeah, that's what I was kind of going to bring up as well. The iCAP seemed to be targeted toward, doing some of this management notification and alarming to deal with the events when they happen. So that's kind of an interesting feature and capability as well. Ving, in terms of what you're seeing with your customers and applications that you're dealing with, are people doing any kind of specialized design around, worrying about what happens when there's an internet cloud outage, and how does Edge Intelligence play a role there?
Well, we work with partners. We have great partners such as Innodesk that they kind of explain some of the technologies that they offer that provides some of that fault tolerance. But as well as our products are industrial grade, utilizing industrial grade components on a particular solution. Having wide voltage support is key for those industries. I would say a deal platform should be just versatile in encompass a set of essential inputs and outputs suitable for that particular application itself.
Right. Okay. Want to remind the audience we do still have some time left, so continue to ask those questions. Take advantage of the expertise we have here. I guess perhaps one more thing we can kind of go around the horn on. There's a lot of great information in terms of these applications, these transitional programs to bring legacy systems, up to be able to accommodate newer sensors and cards. We've seen, the smart factory. Supermicro's talked about a lot of edge intelligence capabilities with GPUs and such. Dave, let's start with you. Maybe you can just. It's a lot of information. It'll take a while for people to kind of go through it all. But do you have one kind of key takeaway, if they remember nothing else, about legacy, dealing with legacy for these IoT systems? What do you think they should take away?
That's a good question. I think everybody needs to consider, there is a level of complexity in regards to bringing newer technology into older facilities and interfacing with older equipment. But they're computers, so anything is possible, right? It's always achievable. You just need to find the right partner to discuss what your goals are and how to get there. And I think that's the most important thing, is to partner up, right? Find companies that can answer your questions and work with you to develop the right solution.
Right. Yeah, that makes a lot of sense. So, they'll know, because it's their core competency, what their ultimate SMART goals are, and then where they have core competency deficiencies, find a partner and learn and move forward. That makes a lot of sense. Veronica, in terms of your Innodesk perspective, what's the key takeaway for dealing with legacy and bringing it up?
Okay. So for our opinion, because we highly recommend implement AIoT with the smart factory, so it's not only depends on the system provider or the component provider. So we also highly recommend customers can work with us together to find the right solution for them. And then for us, since we are the component manufacturer, so once customer can let us know their requirement, we will always recommend because for the AIoT implement in smart factory, so we will work with them to see what system they are using and then what environment they need to always fulfill their needs. Thank you.
Okay, yeah, that makes a lot of sense. In terms of, and that kind of touches upon leveraging your partner's ecosystem and what they've learned as well. So that's a great takeaway. Ving, what are your thoughts on you had your presentation had an interesting dimension of like having an interim solution that you can add smart components to, yet accommodate legacy systems. What's your key takeaway?
Key takeaway is probably I think integrators can better prepare themselves by ensuring that there are expandability support in their embedded systems to meet current and future IoT solutions. So having some expandability in machines offer flexibility and adaptation to new connection media without much additional efforts, especially when we can't really predict the next 20 years to come with IoT and the way it's growing. So new expandability, whether that be M.2 or PCIe functions in a particular gateway or embedded systems. Just having planning for integrators to support the new transmission communication is probably something to think about for future product development.
Right. I mean, that makes a lot of sense. Extensibility and flexibility is key here because the goals, will change. Things are going moving rapidly. So having, partnerships, experienced people behind you, leveraging partners' ecosystems to bring up core competencies, and then, being able to use some of these bridge tools, systems, and solutions is important to also do flexible design so that you can deal with the unexpected later. Well, I guess that answers the questions. I think let's see. I guess there's one more, maybe a lightning round question for Ving. How could embedded systems designers adapt to new connection media and communications protocols for future IoT devices? This kind of dovetails into what you were saying.
Yeah, exactly. Yeah, pretty much. We can't really predict the transmissions, communications that come out in the next 20 years or so, but just preparation ahead of time for integrators and solutions, product development to follow the trend. Of course, IoT device manufacturers will be working with embedded system IoT devices to support those devices and systems as well.
Okay, great. Thanks. Unfortunately, that does bring us to the conclusion of our webcast today. I want to thank Ving, Veronica, and David for sharing your insights on dealing with legacy and industrial IoT systems. We at Open Systems Media, DFI America, InnoDisc, and Supermicro also thank you, the audience, for attending and contributing excellent questions today. The webcast will be posted online at the URL shown on your screen in 24 hours, and an audio-only podcast will also be made available. You can do a web search with the keywords Open Systems Media Events and find all of Open Systems Media webcasts available for download as MP3s. Open Systems Media webcasts are copyrighted and may not be recorded or used in any way without the express written consent of Open Systems Media. Thanks for attending. Have a great day.